For lesson 5, factoring part 1. We're going to do factoring part 1 and part 2. I'll probably just stay separate videos just to stay separate. But anyway, so this is review, and this is what I kind of brought to your attention yesterday, the whole idea of when you factor stuff, you get to zeros and quadratics, right? So we're going to use that knowledge to actually factor bigger polynomials now. Because we know if you check, if I check to see if x plus 1 is a solution, or excuse me, as a factor, and I plug it in, it's going to be a what? A 0 if it is a factor. If it's not 0, then it's not a factor. And that's how we know. And so using that knowledge that we've kind of used for remainder and factor theorem last lesson, we're going to kind of take it a step further today. So here's just the review again. We kind of know with this, okay, I hope you remember, but we know the graph of x squared minus x. If I just go ahead and really factor this real quick, it's going to be x minus 3, x plus 2. And so I know that my zeros are 3 and negative 2. Okay? And then they're doing the thing in Math 20 where they hammer it into you. So X-intercepts, zeros, and roots are the same thing. So 3 and negative 2. Those are all of your roots and X-intercepts and zeros. Okay? So fill in the blanks in the following. It says, and that is important, guys, because on diploma, if it asks you for roots, but you forgot what roots are, you need to know that roots are zeros. So if you only know what a 0 is, you don't know the other two, just remember they're the same. Okay? So I remember on one of the questions we did the other day, it asked for the roots, and I was like, well, what's a root? It's a 0. Okay? So make sure you guys kind of keep that in mind. Here we go. The zeros of the function, the x-intercepts of the graph, and the roots of the equation are the same numbers.
Why does it have a different things? Like one of them is of the function, and the other one is of the graph of the function.
Well, that's just in terms of the context, right? So 0 is the function, so when you plug it in and it makes the function be 0, that's called a 0 of the function. That spot is also where it crosses the x-axis, so it's the x-intercept. And then that spot is called the root when you're solving, because that's when y is also equal to 0. I think that these two actually, Aiden, to me are kind of the exact same, but this is the graphing piece. Okay. All right, so investigating the integral 0 theorem. So that's just to state the fact that the factors of polynomial x squared plus 5x minus 24 is x plus 8, x minus 3. State the zeros. So the zeros are negative 8 and 3. We can see that from the factors. What do you notice about the constant term of the polynomial and the zeros of the polynomial? So this is actually pretty helpful for us. We get the 8, negative 3 as a combination or a product of the 24. When I say factor this, you say multiples of 24, negative 24, that get me 5, right? So that's where we get them. So what do you notice about the constant? It's a product of our zeros. So the point is, negative 8 times 3 is negative 24. The factors of the polynomial x cubed minus 2x squared minus x is negative 2, negative 1, and 1. What are the zeros? 2, 1, and negative, right? Again, what do you notice about the constant term? It's a product of the zeros. Okay? If you multiply the zeros, 2 times 1 times negative 1, you get negative 2. But wait, did I do that wrong? Yeah, sorry. Of the breakdowns of these, sorry, of those numbers. Okay? So it's a product of the zeros constant term. Okay?
So you don't use...
It's talking about these guys. When it says the product is, product is 0 constant term, I do need to put that there. So what it's saying is, when you break it down, it's a product of these numbers. It's a product of these two numbers. So not these two, technically. It's the ones that you see here. So 8 times negative 3, negative 2 times negative 1 times 1. So negative 2 times negative 1 is 2, times 1 is 2. Okay, so not the answers, so excuse me. Okay, but that makes sense because, again, that comes back to that diploma question we talked about how we could find a y-intercept really quickly, right? We could say, well, the y-intercept of this has to be this, because that's going to be the constant, remember? So it's just the idea that by multiplying the constant of your zeros, it gets you the constant of your function. All right. So today, the examples of the previous page illustrations of integral zero theorem, which states the zeros of an integral polynomial function with a leading coefficient of 1 must be factors of the constant term. So what this means is we have to, like, if we don't know, see this right here, x cubed minus 7x minus 6, we can't factor that just normally because it's a cubic. It's not in the correct form. Remember, a correct form to do factoring inspection has to be 2 to 1. That's 3 to 1. So that's not, we're not able to do our normal factoring patterns. And so what you have to do is think about potential zeros. And what tells you the potential zeros? The constant does. Right? Those gives you the potential options to check. So this one right here, you want to check all factors of 6. That's where these numbers came from. What's that? All factors of 6, yeah. But the negative 6 is any factor of 6, including negative 6, yes. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Those are all possible factors of 6. Or negative 6. From like what Aiden's saying, that's fine. Okay, so these are all the potential zeros. So there is 2, 4, 6, there's 8 potential zeros. Okay? All right, so they're giving us the same problem here, so we can kind of steal that answer from the bottom. So we know the list of the potential zeros. Let's write these down here. So our potential zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So that means your potential factors, like the potential factors are x minus 1, x plus 1, x minus 2, x plus 2, x minus 3, x plus 3, and then lastly x minus 6, x plus 6. That's your list. Okay. So students are asked to identify one of the actual factors of the polynomial. Luke was asked to use the factor theorem, and Nicole was asked to do synthetic division. Their work is shown. Okay. So here's the process. Now, once you find one, it gets easier from there. Because once you know one, then the multiple of that has to be similar. So what I mean by that is if I get 2 works, then I know that I'm probably going to look for what? 3. 6 can't happen, right? Because if I have a 2 and a 6, I'm up at 12. So once I get a 2, I know 3 and 1 are options. Why is 1 an option? Because it can be 3 times 2 times 1 to get 6, right? So just letting you know, once you find one, it does get easier. Because if you're thinking it's to take forever, sometimes it can. If you get like a number like 24, that's not awesome. But okay, so here's the left side work here. So she tried x minus 1 as a factor. So she used the remainder theorem. She plugged 1 into the function, and she got 12, negative 12. That means that is not a factor, so x minus 1 is not considered. Okay, she tried x plus 1, so she plugged in a negative 1, and then she got 0. So that means that this is a factor. Okay, and so once you get a factor using the remainder theorem or factor theorem, you can go ahead and say, well, let's synthetically divide that out to see what the quotient is and see if I can factor that. Right? Because we can factor quadratics. We feel comfortable with quadratics. We should be. Okay? So that's what he did next. Or he or she, I forgot what we got on the top there. Luke. So we got right here, we figured out the x plus 1 worked through the factor theorem. That means we try negative 1 for synthetic division. Okay, you have an x cubed, no x squared, and a minus 7x minus 6. Say drop the 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. Negative 7 plus 1 is negative 6. Negative 1 times negative 6 is positive 6. Remainder of 0. So right now, this right here is what's left. X squared minus x minus 6. Can you factor that? Yeah, that is x minus 3, x plus 2. with the x plus 1, right? So that's the entire answer. We'll go to the right side, but that's the entire answer. Okay, that's that x cubed factored. Okay. All right. So we got first one. Just did the same stuff. Tried x minus 1 first. So they start with the plus and minus 1 first. Okay, it's the easy one to try, which is a good one to try. Okay, because 1 a lot of times can be a factor. So 1 did synthetic, didn't work. Got the same negative 12 that Luke got. Okay, for Nicole. Since the remainder is negative 12, it's not a factor. Then she tried x plus 1. She got 0. Okay, now since she already did the synthetic, she got 0. So now she has what she needs to factor. So synthetic can be a little bit faster once you find the 0. Okay, so kind of whichever one you want to use. I don't think one's right or the other. There we go. And so when you factor that, we get the same we got over here. So to finish their work there, along the idea, any questions on the process there? Because I mean, that's essentially it, guys. You're going to have to try zeros to figure out to find them. Okay? And then from there, you probably want to synthetically divide to get a quotient that you can factor or deal with it's a little bit easier. Okay, that's essentially the process. So we got x plus 1, x minus 3, I believe it was, and x plus 2. Then just that quick little constant check to see if you're right. 1 times negative 3 is negative 3, times 2 is negative 6. So we're feeling pretty good about our answer. And I have 3 x's there for x cubed. All right, last page for this lesson here. Okay, so this one, consider the polynomial x to the 4th and 2x cubed minus 7x squared minus 8x plus 12. List the potential zeros. So 12 is kind of not as cool, just because the more factors a number has, the more options you have. So that's just going to make things a little bit more work sometimes. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12.
There's never going to be like fractions.
There could be. I mean, I'm not going to say never. Would be hard, yeah. But if there was a fraction, you could times the whole function by a number to get rid of it. Like if it was 1/4, times the whole thing by 4, make it a 1, I guess. But, yeah. But I think for these most time, yeah, Aiden, we're going to be dealing with whole numbers. Okay, so express the polynomial in factored form. So we want to go ahead and test a couple of zeros to find a 0 now. Okay, so let's just start with 1. I think this one works, which isn't always going to happen. But if I'm going to try p of 1, I get 1 to the 4th plus 2 times 1 cubed minus 7 times 1 minus 8 times 1 plus 12. So we got 1 plus 2 minus 7 minus 8 plus 12. Okay, so I have 12, 15 minus 15, so I get 0. So 1 is a 0, so that means that x minus 1 is a factor. So now that I have a factor, I want to synthetically divide to get the new quotient. Now, what's the problem? Like, am I done after that? No, because this is a quartic, right, if we're using the right vocab word. Quartic, so I'm going to have to probably do it twice. I need to find another 0 after that still. But I restart. So I'm hoping when I synthetically divide, I'm not going to have something as big as 12. Maybe I have like a 4. Okay, so let's do that now. So we're going to go 1, synthetically divide. So 1, 2, negative 7, negative 8, and 12. 4, 3, 2, 1, 0. So we have it all. 4, 3, 2, 1, 0. Okay, so drop it. 1, 1, 3, 3, negative 4, negative 4. I'll wait a second. Let's just get.
Wait, since it's like the 4, you have to get it to the x cubed. You have to do this.
Right, that's what I just said. Yeah, since it's a quartic, when I take this out, I still have to do it one more time. And unfortunately, it looks like we still have a 12, huh? So that's not good. Which we kind of, like, I guess that was kind of dumb to say, well, for me, because if I take out a 1, it's not going to change 12, right? Because 1 times 12 is still 12. Okay, so we have x cubed plus 3x squared minus 4x minus 12. That's what we're dealing with now. So we still have these same numbers that are possible. Okay, so we can try -1 if we want. We could try 2. We could try whatever. Just for the sake of the video, the next one they tried is one that works. That's not always going to happen, though. But if we try 2, because 2 is the one they wanted me to try, so P of 2. Okay, if you put P of 2 into this, okay, you're going to get, it can be into either, I guess, actually. So let me see which one they put into. P of, they actually just synthetically divided, but so we'll just put it into the original. Maybe, do you guys, I think probably checking out the factor theorem is probably easiest. And then you can do synthetic division after that. So that's kind of what I'm thinking. These are going to be a little bit bigger numbers, but that's okay. Minus 7 times 2 squared, minus 8 times 2 plus 12. So 2 to the 4th, we got 16 plus 16. 2 squared, so minus 28 minus 16 plus 12. So 32, 44. 20 and 16 is 44, so it is 0. So it is a 0, so now we can come over here and we can actually synthetically divide it out so we get the quadratic. Now we'll do it to this one though, because we want to keep getting lower. So this one is 1, 3, -4, -12. So just so you're not confused, I put the 2 into the original to prove that it was a 0, which it was. You didn't have to do that because it still would be a 0 from here as well. So you can put it into the new one or the old one. It doesn't matter. But I do want to synthetically divide from the new one. I call this the new one because then I'm going to divide out another x to get an x squared. Okay, so that's what's happening.
So you said you don't have to do that?
Don't have to what?
Like you don't have to go from the new one? You can go from the old one again?
No, if you go from the old one, then you'll get a cube again for synthetic. Synthetic, you want to go from the cube because our goal is to get to square where we can actually factor. So because we already divided out a 1, now we want to divide out a 2 to the new thing. I'm just saying when you're testing the factor theorem, you can test with the new one or the old one. Does that make sense? Okay, so here we go. This is a positive 2, so 1, 2, 5, 10, positive 6, and 12. Okay, so we're left with x squared plus 5x plus 6, which we're happy because that's a pretty simple one. 3 and 2. So that means we are here. So state the zeros. Our zeros are 1, -2, -3, and -2. Oh, I'm sorry, positive 2. So I can put plus or minus 2. 1 plus or minus 2 and -3 are your zeros. And then right below here for the roots, same thing. 1 plus or minus 2 and -3. And that's it.
You know it's plus or minus 2 but not negative.
Well, because we have 2. We have a -2 and a positive 2. That's just because that's what we have for our factors. We have 4 numbers, right? I'm just writing it because we got the answer of -2 and positive. If you want to write them separate, you can. But we have 4 answers, right? Yeah. And then it just happens that 2 and -2 are 2 of those 4 answers, so I just wrote plus or minus 2. So you can write it separate. Okay? All right, last one for this lesson. Okay, consider the polynomial function x cubed minus 3x squared minus 3x plus 1. Find the zeros with a graphing calculator. Okay, so we'll do that. Okay, I see what happens here. So what's happening here is that, guys, we have to understand that not all polynomials are going to go through nice whole numbers. And so the ones we just did, those went through nice whole numbers. That's not always going to be the case. Okay? We still have remember the quadratics in Math 20? use quadratic formula, you got these ugly decimals. That happens. We don't have nice, smooth for everything. So what they're going to have you do on this one, we can bring up the calculator. We'll go, let's put this one in our calculator. We're going to find the zeros. Okay, so we're going to clear the absolute value stuff from Math 20. Okay, so we're going to put in x cubed minus 3x squared. Whoops. Minus 3x squared minus 3x minus, plus 1. Okay. We're going to graph that. And we want to do is that we want to see if any of those look like a whole number. Okay? Because any of those look like a whole number, because what they want us to do is we'll find all of our zeros. We'll find them all because it tells me to. And this it wants us to use synthetic division to determine the exact value for the other one. So what that means to me is that hopefully one of them will be a whole number. And then the other two I'm going to get like a radical or exact value, something that I don't want decimals for. So let's just find all three of these real quick. Do you remember how to do that? Second, trace 0. Okay, so here's my cursor. I got to go to the left of 0. I'm going to find the 0 on the far left first. Okay, so I'm going to go over here. I'm left of it. Enter. I'm going to go just past it. Right there. Hit enter. Enter. -1 is a 0. Cool, that's a whole number. Okay, so -1 is a 0. You guys write these down because I can't write it right now because I'm going to use it. Okay, now we do it again. Second, trace. I have to do this process 3 times because there's 3 zeros. There's a 0 right here in the middle. Let's figure what that is. I got to be on the left side of it. Make sure you get over the hill there. So I'm over the hill. Hit enter. Go below it. Enter. Get close to it. Enter. The second one is 0.267. They said nearest hundredth, so that's going to be 0.27. So you guys write 0.27. So we have -1 and 0.27 so far. And the third time, second trace 0. We come over here, come all the way down. Enter. Come to the left of it, now go right of it, enter, get close to, enter. 3.73 is the third one. So we have 1 whole number and 2 not whole numbers. So when you get those 2 decimal guys, we want those as exact values they want for the next part of the question. Okay, so what we just got, we got -1, 0.27, and 3.73. So since we have a whole number, we can divide out synthetic division, the -1, right? And get a quadratic we can use quadratic formula on. Okay, so -1, we're going to divide that out. So we got 1, -3, -3, and 1. 1, -4, 4, 1, -1, 0. So that's just confirming -1's a 0. What's left is x squared minus 4x plus 1. Now that's not factorable, obviously, because 1, okay, because 1 only has 1 and 1. That can't give me -4. Okay, so this is where you got to use your quadratic formula skills. Quadratic formula, remember, is -b plus or minus square root p squared minus 4 over 4c all over 2a. So if you need it, they'll give it to you. I don't think you have to memorize the quadratic formula for the diploma because it was on your 20 formula sheet, so I'm sure it'd be given to you. Okay, so -b, so +4 plus or minus b squared, -4 squared, 16, minus 4 times 1 times 1, so, and then 2 times 1, if I plug in all my a, b's, and c's. It's nice that a and c are 1s. So the top there is going to be 4 plus or minus 16 minus 4, which is 12, all over 2. We can break down 12, back to your Math 20, 4 times 3. The 4 comes out as a 2. So it's 4 plus or minus 2 root 3 all over 2. And last thing you can do is what? Cancel, like the 2 goes into both of them. So 4 divided by 2 is 2. 2 divided by 2 is 1, so it's just 2 plus or minus root 3 is a simplified answer. 2 plus or minus root 3 is a simplified answer. So 2 of them, plus or minus. Plus or minus signifies you're doing 2 operations, so you have 2 answers. Right? 2 plus the root 3 and then 2 minus the root 3. And so your third answer is at -1. So that's your 3 answers. Exact. Right. Quadratic formula gives you the whole thing, gives you both answers. Take out a 2 where? I divided, actually. 4 divided by 2 is 2. 2 divided by 2 is 1, so that's 1 root 3. Is that what you mean, or? Okay. Yeah, but we don't take it out because we're actually doing the division of it. Because you're thinking if they had the same thing, you could pull it out and leave it out front. We're not doing that because it's on the bottom. So we're actually dividing it. Okay? All right, that's all for this one. So I'll just